My topic is about Taguchi method application for optimization of parameters that will improve surface roughness of lathe. So what is Taguchi method? Taguchi method is a statistical approach to optimize the process parameters and improve the quality of components that are manufactured. So what are the general steps involved in Taguchi method? The general steps involved in Taguchi method is to identify the main function and its side effects. In this case, the main function of this experiment is phasing operation on MS workpiece, mission surface workpiece, MS workpiece, using lathe mission, and the side effects include variation in surface finish. So, and the next steps involved is to identify the noise factor and test condition and quality characteristics. And it also includes the conduction of the. I need to draw the matrix experiment and examine the data and need to predict the optimal control factors, levels, and its performance. As you can see, the quality character, when you look at the quality characteristic, it is surface finish. The surface finish of the metal need to be good, and in this case, the workpiece and metal that I considered was mild steel. Uh, Next, I need to construct the control factors and noise factors uh, matrix, where the control factors are cutting speeds, depth of cut, feed rate, nose radius, and coolant. And those noise factor include for cutting speed is vibration, the depth of cut it is raw material variation, for feed rate it is machine condition, for nose radius it is temperature, for coolant it is operational skill. The smaller the S by N ratio, the better it will be. The workpiece it will be. So the S by N ratio will be given as minus 10 log 1 by n summation of y square yi square y I equal to 1 to n. Next thing, control factor on this level. These are the factors on the level that I considered. For the level 1, the cutting speed was 960. Since, as you know, for lathe we have 3 levels. Uh, for level 2 is 640, for level 3 it is 1280. And depth of cut 0.3, 0.2, 0.4. And the feed rate was 145, 130, 160. So in order to select the orthogonal array, I need to calculate the degrees of freedom. For mean value, it is 1, and for each of the remaining factors, uh, 2. So 2 into 4, 8, and total degrees of freedom are 9. So L9 array is the most suitable orthogonal array. The surface roughness was measured using the surface roughness tester. The table value shows the measured value of surface roughness obtained from different experiments. I need to conduct the matrix experiment. There for experiment 1, these are the values that I got for this respective velocity, time, and the feed. Experiment. Now I need to find out I need to mention the experiment data. Since the objective is to get a smaller S by N ratio, the S by N ratio of the all experiments are calculated and tablet shown below for the experiment. These are the S by N ratio that I got, total 9. The S by N ratio for the control calculated can be calculated through this formula. SS1 equal to the summation of these 3, and S2 for feed, for time. And similarly, for the corresponding cutting speed at level 1, it could be calculated as SS1 by 3 and average by n ratio. And next thing is after calculating the average S by n ratio for all these 3 factors, SSJ and SFG and STG, where SSG include the speed factor, where SFG include considering the feed factor, and for T it's time factor. A full factor analysis is constructed by taking all the possible combination. We get a total combination of 27. Uh, and confirmation experiment could be conducted using the speed 960 velocity of 960 rpm with 0.3 mm depth and a cut of 145 mm per minute. It's a feed rate actually. And with the and we got the surface roughness for each of these experiments. The mean was 2.448. After taking this whole data and after considering on what the result was, and the sum of summation squares percentage for the speed parameter was more. So it can be said that the contribution of cutting speed is more significant to the surface finish than the depth of the curve, because it is 18.56%, whereas the speed parameter is 58.49. These factors are more significant compared with the feed. It is clear that the effect of noise factor 7.3 on surface finish is very less as compared to control factors. Thank you.